Good afternoon, students. Okay, last week we have started block 3. In that we have seen matrix characteristic values and vectors. In that unit 7, elementary transformation and rank of a matrix. So I have told what are the elementary transformations and also how to find the rank of the matrix. When it is a non-singular matrix, 3 by 3 non-singular matrix, then we'll get the rank as 3. And when it is a singular matrix and the minor of A is not equals to 0, we'll get rank of A equals to 2. Okay. So today we'll see echelon form, in that how to find the rank of the matrix. So for the echelon form, what is the procedure that you have in your textbook? You can see the procedure how to convert the given matrix into echelon form. So that one you have in your page number. Page number 77. That is the definition is there, 7.2.10. That is echelon form of a matrix A is said to be in echelon form if every row of A which has all its entries 0 occur below every row which has a non-zero entry. Okay. So first one should be like this. And here you may get, if you convert like this, first element of the first row and first column should be 1. Under that it should be 0. And under that it should be 0. And if you convert like this any matrix, then we call it as a echelon form. Okay. That only given in your definition. So one example problem is given in the textbook, that is 7.2.11. So we'll see one problem from the check your progress to find the rank of the matrix. Okay, problem is from check your progress. So find the rank of the matrix. Find the rank of the matrix. A is equals to 1 minus 1, 3, 6. 3, 11. Okay, this is the given matrix A. For this, we have to find the rank of the matrix by using by converting the given matrix into echelon form. Okay. So first in the solution you write let A is equals to, in the given, whatever it is there, you write here 1 minus 1, 3, 6, 1, 3 minus 3 minus 4, 5, 3, 3, 11. Okay. This is the given matrix. Now, for the echelon, for converting the given matrix into echelon form, compulsory you should use only the elementary, that is row elementary transformations only. Okay. Not the column one, only the row one. So, if you see the order of this matrix, here 3 rows are there and 1, 2, 3, 4. 4 columns are there. That means the order of the matrix is 3 cross 4. Okay. 3 by 4. This is the order of the given matrix. Now we have to convert this into echelon form by reducing the row, that is the rows, any rows. So the what is the rule for the echelon form is that first element should be 1. After that, you have to convert this into 0, or this may be into 0, this into 0, and this into 0. Okay, that is the conversion of the given matrix into echelon form. Now you write here, we reduce the given matrix A into, reduce the given matrix A into echelon form. Echelon form to find the rank of matrix A by applying elementary transformations. Okay. So here this already 1 is there. You have to convert this as 0 and also this as 0. So we can write this. This is R1, this is R2, this is R3. So R2 minus R1 and next R3 minus 5 into R1. So this will become 0. At a time we can do. So by R2 is R2 minus R1 and next one is R3 is R3 minus 5 R1. So by applying these two elementary transformation, we are converting this one and this one as 0. Okay. So by applying this, first one is like that only. That is 1 minus 1, 3, 6. Next 1 minus 1 is 0. 3 minus of minus 1 means it will become 4. Minus 3. Minus 3 means minus 6. Minus 4 minus 6 means minus 10. Okay. 5 into 5, no? 5 minus 5 means this is 0. 3 minus 5. This is minus of minus, it will become plus. 5, 3 means 8. Next 3 minus 15. So minus 12. Next 11 minus 30. 30 minus 11 means 19 you will get. So minus sign is there here. So you will get minus 19. Okay. So this is 11. 11 minus 5 is 6 minus 30. Okay, 19. Minus 19. So now here whatever this second row is there, you can divide it by 2. Okay. R2 by 2. R2 by 2 means 1 minus 1, 3, 6, 0. This is 2. This is minus 3. This is minus 5. 0, 8, minus 12, minus 19. Now we have to convert these elements as 0. So R3 minus This, if you'll do 4 times, 8 minus 4 of this one means these two will get cancelled. Whatever this element is there, that will remain here. So for R3, R3 minus 4 R2. So it is equals to 1 minus 1, 3, 6, 0, 2, minus 3, minus 5. And this is 0. And this is minus 4, no? 8, 8, both will get 0. Minus, minus of minus. So it will be plus 12 and this is minus 12. 0, minus 19. This is plus or minus. Both are minus, no? So it will become plus. 5 fours are 20. 20 minus 19 means we'll get it as 1. Okay. Now here we cannot cancel out this one and we can't make it as 0. Why? Because all these elements are there. No? If you do again subtraction with them, again you will get the elements here. So we can't cancel this one. So it has converted into the echelon form. That is 1, after that 0, and after that the elements are 0. Okay. So here non-zero rows are, this is also, if this also becomes 0 means only the non-zero rows are only 2. But here in third row also you have one single element is there. Therefore the non-zero rows are 1, 2, 3. 3 rows are there. Therefore the rank of the matrix is 3 here. So here you write we reduced the given matrix A into echelon form. So we have converted this into echelon form. Now you write the number of non-zero rows is the number of non-zero rows are 3. Therefore, the rank of matrix is, the rank of A is 3. That is, we can write it as row of A equals to, okay. So like this, we have to find the rank of the matrix. Okay, like this, we have to find the given matrix rank by reducing the matrix into echelon form. So in some cases, if it is a 4 by 3 matrix, that is 4 rows are there and 3 columns are there, then we convert that is second row and third row, then fourth row also as 0 zeros. In some cases, you may get here 0, here 3 zeros, and last whatever row is there also will get all the zeros. Okay. With the help of the echelon form also, we can find the given matrix rank. Okay. So on echelon form, you have example problems and also exercise problems are there. So try to practice those all problems. So in this only, next topic is a normal form of a matrix. Here, normal form of the matrix means you have to convert the given matrix into the identity matrix. That is 3 by 3 identity matrix or 2 by 2 identity matrix. So by applying the elementary, that is row operations and also column operations. For the normal form, we use both the operations, that is column and also row operations will do. Okay, normal form of a so we have the definition of the normal form of a matrix. So in that, how we convert the given matrix that is given, that is suppose A is equals to Aij. That is I is the row and J is the column here. And order is in the form of M cross N matrix of rank R. Okay. So small r also will represent, or row also will represent for the rank of the matrix. Rank or then the matrix like this. If you convert IR 0, 0, 0. So this I represents the identity. So identity matrix means if it is a 2 by 2 identity matrix means 1, 0, 0, 1. And if it is a 3 by 3 identity matrix means 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay. So you have to convert the given matrix into like this matrix. Then if it is an identity of 2 by 2, then the rank of that matrix is 2. And if we get the identity matrix of 3 by 3, then we'll tell that the rank of the matrix is 3. Okay. So like this conversion is called as the normal form of a matrix obtained from A, that is matrix A, by a finite chain of elementary transformations. Elementary transformations is called, so is called the same here, the normal form of a matrix. So this is the definition of normal form of a matrix. So for this, one example problems are there in your textbook. You can see those example problems. So one problem regarding of the normal form of the matrix. Okay, today we'll discuss about that one, how to solve the problem. Find the rank of the matrix. So here the matrix is given as 1, 0, 0, 1, -2, 1. So this is the given matrix by reducing into normal form. So we have to reduce the given matrix into the rank of the matrix into normal form by using both elementary transformation. For the normal form, we can use the row, that is a row transformations, and also column transformations you can use. Okay. So for any, whether it is a 2 by 2 or it is a 3 by 3 identity matrix, first element should be 1, 0, 0, 1. So all other elements, you have to make it 0. If it is a 3 by 3, if it is a 3 by 3 matrix, then 1, 0, this you have to make 0, and this one also 0. 0, 1, this is 0, this is 0, and 0, 0, you have to make this as 1 and 0, and this you have to make all the elements 0. Okay. So for this one, first you can divide here whatever the last row is there, no, R4 by 2. Then you can convert this one into this as -1, 1, you'll get here 4 and 0. Okay. So take here 1, 0, 2, 1, 0, 1, minus 2, 1, 1, minus 1, 4, 0, minus 2, 2, 8, 0. So this is the given matrix. So by applying the, so first one is R4, you divide it by 2. R4 by 2. Okay. So when you divide that by 2, you will get it as minus 1, 1, and here 4. And R3 and R4 both are same. So you can do the subtraction of those two. Then this whatever the fourth row is there, that row whole elements, all the elements will become 0. Right. Yeah. So here R4 by 2, if you do the division of the R4, then you will get it as, that is A is equals to, first one is 1, 0, 2, 1, next 0, 1, minus 2, 1, next 1, minus 1, 4, 0. So last one is, by you are dividing by 2, no? So here you will get it as minus 1, here 1, here 4. So 0 by 2 means you will get here 0. So both these are same, no? R3 and R4 are both are same. So if you do the addition of them, then you will get it as, okay, this is 4. So first you do, this is minus is there, here minus is there. If you add these two, this will become 0, this will become 0. Here you will get it as 8. Okay, so R4 plus R3. Okay, so it is equals to 1, 0, 2, 1, 0, 1, minus 2, 1, next 1, minus 1, 4, 0. Here minus plus, it will become 0. Okay, this is 1 and this is minus 1. Both is 0. And 4 plus 4 is 8. And next this is 0. Okay. Now we can, here up till now we have used the row operations. Now we can use here for this column. You can divide it by 2. Okay. So C3, this is C1, C2, C3, C4. So C3 divided by 2. Okay. So C3 divided by 2 means 1, 0. This is 1, 1. This is 0, 1, 0, 1, minus 1, 1. Next 1 minus 1. This is by 2, no? 2. Next 0. So this is 1 minus 1. This is 2. And this is by 2 means 4 you will get. So 0, 0, 4. And this is 0. Okay. Now we have to make this as 0 and this as 0. Okay. How you can make we can do the subtraction of these two. What you will get? 1 minus 1 both. This is 1 minus 1, 0. And this is 2 minus 1 means you will get 1 here. 0 minus 1 means again you will get 1. Okay. And if you do this 2 means this is 1 minus 1, this is 0. 1 minus 1 means you will get here 2. And next 0, 2 means again 2 you will get. Minus 1, 0. Next 1, this is 1. Okay, anything you can do. C4 minus C1 if you do. C4 minus C1. Okay. So 1 minus 1, this will become 0. 1 minus 0 means it is 1 only. C4 minus C1. So you'll get here minus 1. Next, this is all same like that only. Next, again, you can do one more is C3. C3 means C3 minus C1. 1 minus 1, this is 0. This is same minus 1 we will get. 2 minus 1 means 1 here. And 4 minus 0 means 4 like that only you will get. Okay. And one more thing. Okay, first you do C3. Like this you can write C4 in C4 minus C1. C3 is C3 minus C1. Okay. So it is equals to 1, 0. C3 we are doing this. 1 minus 1 means 0. 0 minus 1 means it is minus 1 like that only. Next, C3 minus C1. So you will get 1. 1 minus 1 here 1. Next 0, 0. C3 minus C1. So you will get 4. Next C4 also we have done. 1 minus 1 here 0. This is 1 like that only. But here C4 minus C1. So we'll get here minus 1. Next 0, 0 is there 0. Okay. So first we have completed this all as 0. So 1 is there. So 0, 1. So you have to make these two as zeros. And here this you have to make it as 0. If you add C4 and that is C4 plus C3. And R3 divide by 4. Okay, R3 if you divide by 4. So a normal form is somewhat lengthy process will be there. The thing is you have to convert it into any identity matrix, either 2 by 2 identity matrix or 3 by 3 identity matrix. So when you apply this, C4 only we have done. So 1, 0, 0. Yeah, this is also 0. Next is C4 plus C3. No. 1, 0, 1, minus 1. Minus 1 plus 1 means it will become 0. 1 minus 1 like that only. 1 minus 1. 1 minus 1. So this is 0. This is 0, 0. By 4 we have divided. No? So 1 and this is 0. Okay. C4 plus C3. No? Wait. This is C4 plus C3. Okay, this step we'll do again. So this is 4 here. And here C3 plus C4. No, so 0 plus 4 means this is 4. Now R4 you divide by 4. Okay, this R4 you can divide it by 4. Now again, so this you have to make this as 0, and next these two elements as 0. So first you divide R4 by 4. So you will get 1, 0, 0, 0, 0, 1, minus 1, 0, 1, minus 1, 1, 0, 0, 0. This is 1, 1. Okay. Now this has 0 now. So 1 minus 1, 0. R3 minus R1. So 1, 0, 0, 0, 0, 1 minus 1, 0. 1 minus 1 is 0. This is minus 1 like that only. 1, 0, 0, 0, 1, 1. Okay. Now, first you will make this as 0. So C4 minus. So these two if you add, that is R3 plus R2. So you will get it as 1, 0, 0, 0, 0, 1, minus 1, 0, 0, minus 1 plus 1, 0, 1 minus 1, 0, this is 0. Next 0, 0, 1, 1 is there. Okay. Now C4 minus C1 or C3 minus C1 you can do. C3 is C3 minus C4. So you will get this as 1, 0, 0, 0, 0, 1, minus 1, 0. C3 minus C4 means here only minus 1 you will get. So 0, 0, 0, 0. This is 0, 0. C3 minus C4. 0. Here 1. Okay. Now it is the 3. You may get 3 by 3 identity matrix or 2 by 2 identity matrix. Here minus 1 is there. So C3 plus C2. C3 is C3 plus C2. So you can convert it as, I'm using single operations. You can use at a time 2 operations also. So 1, 0, 0, 0, 0, 1, C3 no. So this is 0, this is 0, 0. So you can interchange even this also. R3 by R4. Here you can write even R3 as R4. Okay. So R4 here means 0, 0, 1 here and 0, 0, 0, 0. Okay. Now see. Here interchange this C4 as C1, C3. So C4, this is for interchange symbol, okay? C4 as C3. So you will get it as 1, 0, 0, 0, 0, 1, 0, 0, 0, 0. This is here, no? C3 it is going to C4 and C4 you are getting as C3. So 0, 1, 0, 0, 0, 0, 0. So now we got the identity matrix of 3 by 3 matrix. So it is equals to, we can write it as IR or I3. So 3 by 3 identity matrix, no? So it is, R value is 3 here. So 0, 0, 0. So what is the rank of the matrix? The rank of the matrix is So therefore, the rank of the matrix is 3. Therefore, the rank of matrix A is equals to 3. That is, we can write it as row of A is equals to 3. Okay. So here, when we got like this values, if you do again any operations also, you can't make this as 0. Okay. So by this, you can convert the given matrix into any identity matrix. If you are getting, in some cases, even this one also may become 0, then we will be left with only 2 by 2 identity matrix. Then the rank of the matrix is 2. Okay, this is the procedure for normal form of a matrix. So like this, we have to convert the given matrix into normal form and we have to find the rank of the matrix. So by this, we are completing the unit 7. So finding the rank of the matrix is the main concept in the unit 7. Next, we have the finding the system of linear solution for the system of linear equations. Okay. So for that, we need to find in that also we'll have the rank of the matrix. In that, homogeneous linear equations and also non-homogeneous linear equations will be there. For that, we need to find the rank of the matrix. Okay, unit 8 is system of linear equations. That is system of linear equations. Unit 8 is system of linear equations. System of linear equations. Okay, it is system of linear system of linear equations. So this is the unit name. So in lower classes, we have seen the linear equations of the with two variables and also with three variables also we have seen. So here you may have the more than that. So more than that variables you can see in this unit for converting the, that is for finding the rank of the matrix and converting them into either echelon form or any with the help of any row transformations or also column transformation. You have to convert them, the given linear transformations, and also we have to find the rank. Okay. So in this, you will have two types of linear equations. First one is the homogeneous linear equation and next one is the non-homogeneous linear equation. So by seeing that problem, you can identify whether the given problem is a homogeneous or non-homogeneous one. Okay, homogeneous means, so you have to identify that one, whether it is a homogeneous or non-homogeneous linear equation. So homogeneous means it will be in the form of Ax is equals to 0. Okay. So x is here the variables you will have and A is the given matrix and whatever you have on the right hand side, those values will be all zeros. Okay. So and the form will be like this: A11x, x1 plus A12, x2, so on up till A1n, xn equals to 0. Next, A21 x1 plus A22 x2 plus A2n xn equals to 0. So like this, you will have the form. Last one is A m minus 1 x1 A m minus 2 x2 plus so on A mn xn equals to 0. So like this, you will have the form of the linear equations. On the right hand side, if you have the values as 0, then we call it as a homogeneous linear equation. Okay. So equations is a, we can call this as a, is a homogeneous linear equations. Okay. In n, here whatever xn is there, no? So if 4 is there, x1, x2, x3, x4 means here 4 unknowns are there. So that means how many variables are there in the given linear equation, then we call them it as unknowns of the given linear equation. Okay. So homogeneous equations in n unknowns. That is x1 comma x2 up till xn, like this. And here from this, if we take A, let A equals to, that is the matrix means A11, A12, so on up till A1n, A21, A22, so on up to 2n. Like this, A m minus 1, m minus 2, so on, A mn. So this is the matrix A. And here Ax equals to 0 now. X equals to x1, x2, so on up till xn. And 0 is 0, 0, 0. Okay. So like this, whatever the linear equations will be there, that linear equations are called as homogeneous linear equation. Okay. So for this, whatever the matrix say, we have to convert that into echelon form and you have to find the rank of the matrix and we have to find the solution for this one. So the main concept is finding the solution for the homogeneous linear equations. So that is a concept you have in this unit. Okay. Next, for the homogeneous and also for non-homogeneous linear equation, we have the working rule to find the rank of the matrix and to find the solution for the linear equations. So three conditions are there. So here already we know that we represent the rank of the matrix as small r. And here, whatever the n is there, this n is the number of unknowns given in the linear equation. With the relation of r and n, you have the three conditions are there. That in the three conditions, we'll find the whether only one solution, unique solution, or infinitely many solution, or any. We'll find any one solution you'll get, or means unique solution is the one solution, or you may get that is no solution will be there, zero solution. And third one is the infinitely many solution. Three conditions will be there for rank of matrix small r and also small n. There will be a relation that if the help of that working rule, we have to find the rank of the matrix and also hey. So first thing is you remember the how the formation of the homogeneous linear equation will be there. So after that, we need to know the working rule for finding the solutions of the equations Ax equals to 0. Okay. So that even you have in your test book, you can see from the test book. So if you know the working rule, then easily we can solve the problems. So Ax equals to 0, that is homogeneous linear equations you will get for the 5 marks question in the section A. And non-homogeneous equations you will get for the 10 marks questions. So working rule for finding the solutions of equation Ax equals to 0. Okay. So the equation of like this form, we need to find the what is the working rule for that one. First one, consider the given m equations in n unknowns. Then the quotient matrix A will be of the form that is starting what it is there in the test book in page. You can see in page number. So whole thing I am not writing. Just the three cases will be there. The three cases are enough for finding the solutions. That is unit 8. Page number 88. So working rule for finding the solutions of the equation Ax equals to 0. So the matrix will be of the form m cross n. That is the order will be m rows and n columns. So matrix will be in the form of m cross n. And here rank we represent it as small r. And n is equals to number of unknowns. Okay. So with the help of this r and n, we have the relation will be there. First case is let R be the rank of the matrix A. Then R is either, you will have the two conditions. First condition is then R is either R equals to n or R will be less than n. Only these two conditions arise. R may be equals to n, that means number of rank of the matrix and number of unknowns both will be equal, or rank of the matrix will be less than the number of unknowns. Okay. So in that case, first we have to find the rank of the matrix A by reducing to echelon form by applying row operations only. See here the condition is given only row operations. So for the normal form, we generally use the two operations, column and row. But here for converting the echelon form, we will use only row operations. So in that case, first one is if R equals to n, what is the condition? If R equals to n, the equation Ax equals to 0 will have R minus n. R equals to n means R minus n. That is n minus n is equals to 0. That is no linearly or linear independent solution. The solutions are called linear independent, no linear independent solutions. When r equals to n, r place we are writing n. So n minus n means we will get 0. So no solution for the given system of linear equation. Independent solutions. In this case, x1 equals to 0, x2 equals to 0, so on up till xn is equals to 0. Is only the solution. Is only the solution. Okay. Next, case 2. Case 2 is r is less than n. So if r is less than n, then the equation, ax equals to 0 will have n minus r solutions. N minus r linearly independent solutions. Okay. So any in that also we have some another condition is there that you can see from the textbook, that is any linear combination of these solutions is also a solution of ax equals to 0. Therefore, in this case, ax equals to 0 will have infinitely many solution. Okay. So for second case, you will get infinitely many solution and you will have whatever the linear independent solutions are there, they are n minus r. Means if you think n are 4 and r is 3, then 4 minus 3 means 1. So you will get the one linearly independent solution. Here, both are same, so 0. So no solution. But here you will get a 1, anything depending upon the values here. So you will have the n minus r linearly independent solutions. Case 3. Case 3, suppose m is less than n. So third condition is, so m means here number of rows and n means here number of columns. That is m cross n. Okay. So that is m, whatever m value is there, that is less than n. Then r is less than or equals to m. We have r is less than n. So the number of solutions of the equations will be infinite. So infinite solutions will be there even in the third case also. That is suppose m is less than n. Since r is less than or equals to m. R may be less than or equals to m. We have r is less than n. So the number of solutions of the equation ax equals to 0 will be infinite. Okay. So these are the three conditions for finding the solutions of the given linear equations. So if you remember these conditions, with the help of this, we can see how many solutions we are getting for the given linear equation. First one is, you have to see what is the order of the given matrix. It may be 4 by 3, 3 by 4, or 3 by 3, or 4 by 4, like this, any matrix you will have. So, and we have to see, means we have to find the rank of the matrix by converting the given matrix A into echelon form. By converting it to echelon form, we can find the value of R. N is nothing but number of unknowns. That is, X values will be there, no? In some cases, you will have X1, X2, X3, or in some case, you will have X, Y, Z, like that. So those are called as the unknowns. And then if R, the two conditions arise, first one is either R is equals to N or R will be less than N. Okay. So first case is if R equals to N, N minus 1 means 0. then the number of linear solutions is 0 you will have. So no solution for the linear equation. If R is less than M, then the equation will have N minus R linearly independent solutions. And third one is, suppose whatever the M cross N is there, no, in that M value is less than N, and also R value is less than or equals to M. Suppose if you think M is 4 and R rank is also 4, both will be equal. R is 4, 3. Means this is 3 and this may be 4. Why? Because R is less than M, no? So 3, 4. We have R less than N. So the number of solutions of the equation will be infinite. Okay. So for this, if it is less than 1, less than N, directly you will have N minus R solution. Here third case, almost on these two cases only you will have the problems. Third case, you may, by seeing the problem, you have to understand that one. Okay. So we'll see the problems on this in the next week. So these, whatever the homogeneous linear equations are there, the problems will get only conversion of echelon form, then finding the solutions will be there. So in that case, you will have only the 5 marks. You will get the problems for only 5 marks. For the non-homogeneous, somewhat lengthy process will be there. So for that, you have to convert the augmented matrix. And for matrix A, we have to find the rank. And also for the matrix AB, we have to find the matrix rank. Then we have to compare them. And then you have to see the solution for that one. So somewhat process will be lengthy. So such type of problems you will get for the 10 marks question. So this one is only for the 5 marks. So this unit 7 and unit 8, both are the very important. And unit 9 also, you will have the Cayley-Hamilton theorem is there. And also finding the inverse of the Cayley-Hamilton theorem is there. So these, from these, whatever the topics I have told, 2 10 marks question you will get, and 1 again 2 5 marks questions you will get. And whatever the rank elementary operations is there, no, the rank of the elementary operations do not alter the rank of the matrix is there. That is a very lengthy one. So you have the chance even for getting the 20 marks question also. Okay. Next we'll see the, next is the holiday. After that you have the classes there. On the day we'll see some problems on this one.